If we have a straight line, we can find the slope. And another name for slope is rate of change. But when you have a line that's either curved or doesn't have a consistent slope, then we have to do something a little different. We're not going to find our rate of change. We're going to find what's called our average rate of change. And your average rate of change is just the slope of the line that joins 2 points on the graph. Okay? They may not be consistent on your line, okay, but we're looking for the average rate of change. So if I were looking at these graphs, okay, these are not linear equations, but we can find the rate of change between these 2 points simply by finding the slope of the line that connects those 2 points. So we can do that for any of these situations, including a situation where we don't have a line, okay, a connected function, but we have dots. Okay, we can just pick the 2 dots where we're looking for the average rate of change and find it in between those 2 dots. Now the good news is finding the average rate of change is going to be the same process that we used when we found our slope or our rate of change when we had linear equations. Okay, let's look at this situation. How did the temperature change between 4 p.m. and 10 p.m.? Did it go up or down? So the first thing we need to look at is where is 4 p.m. and 10 p.m. on this graph. So these are our hours since noon. So 4 p.m. would be 4 hours since noon. That's this point right here at 4:25. So my temperature is 25 degrees at 4 o'clock. At 10 p.m., we're down here at 8 degrees. So if we're looking for the rate of change between these 2 temperatures, I want to know if that rate of change went up or down. And hopefully you can see from here to here, our temperature is falling, it's going down. Okay. In order for us to find the average rate of change, we need to look at these 2 points, kind of like our starting point and our ending point. And what we're going to do is we're going to find the slope that goes between those 2 points. Okay, so I'm looking for the slope that would go between these 2 points. So what I'm going to do is I'm going to find, remember, slope is going to refer to our change in our x values and our change in our y values. We're actually going to do the rise over our run, so our y values come first. So the first thing I'm going to do is look for how my temperature changes from 25 to 8. From 25 to 8, we drop 17 degrees. Okay, this is a drop of 17 degrees, so we're going to write minus 17. Now the next thing I need to do is look at my run, or the change in my x values, to go from 4 o'clock to 10 o'clock. That's an increase of 6 hours. So to find my average rate of change, what I'm going to do is I'm going to set up my change in y compared to my change in x. My change in y was negative 17. We dropped 17 degrees, and that was over a time period of 6 hours. Okay, this is almost finished now. Okay, what we need to do is we need to turn this into a decimal so that we can really understand what's going on. We're looking for our unit rate. Okay, so we don't want to know how much it changed in 6 hours. We want to know how much it changed in 1 hour. So I'm going to do negative 17 divided by 6, and that's going to give me this big long decimal. What I'm going to do is I'm going to round that decimal point to just 1 decimal place. So instead of negative 2.8333, it'll just be negative 2.8. And what that means is my temperature dropped, because of this negative sign, 2.8 degrees every hour. And we can do these types of problems from a graph, like we did here, or we can also do them from a table. But what's important for you to remember, when we looked at our graph, we looked at our starting point and our ending point, and we didn't worry about any of the values in the middle. We're going to do the same thing when we look at our table. Okay? So we want to find the average rate of change between noon and 4 p.m. Well, this is all of these values right here that are listed on the table, or on this graph. I just put them into a table here. So noon is going to be right here. This is going to be noon, because that's 0 hours since noon. And then 4 p.m. is going to be right here. Now, when we do these problems, it's important for you to know we don't care about any of these other values. Okay, we just want our starting point and our ending point. So we can actually just ignore the rest of these. And what we're going to do is we're going to create a table that just has my starting point and my ending point. So we'll have our x and our y value. This is my starting time at noon. So at noon we had 18 degrees, and then my ending time was 4 p.m. So at 4 p.m. we had 25 degrees. And now I'm just going to look for my average rate of change. I'm going to look for my change in my y values. To go from 18 to 25, that's a change of 7 degrees. And to go from 0 to 4, this is going to be a change of 4 degrees. Okay, now both of these are increasing. My time is increasing and my temperature is increasing. So then I'm going to set this up showing my change in y compared to my change in x. And I'm sorry that my colors here don't match my colors there. Okay, but my change in y is right here. So I'm going to change my colors here. That's a 7 plus 7. My change in x is going to be here. That's a 4. So my change in temperature is 7 over 4. Again, we want to make this into a decimal, so that's our unit rate. So we'll do 7 divided by 4, and we get 1.75. So my average rate of change is going to be 1.75. Okay, it's positive, so that means my temperature was going up 1.75 degrees every hour. So it went up 1.75 degrees per hour. Now, it's important to know this is an average rate of change. If we look at these temperature changes, it's not always increasing by 1.75. Right here, okay, the temperature didn't change at all. And right here, it's only changing by 1 degree. But when we look at the average temperature change over this whole time period, that's when it's 1.75. And we can do these kinds of problems, again, looking at intervals on a graph, like if we have a connected graph. So what is the average rate of change of the population between 1930 and 1950? Okay, so what we want to do is we want to look here from 1930 to 1950. We're looking for the average rate of change for that line. So we're going to start off with our table from 1930 to 1950. And at 1930, we can see that we had 40, but be careful, this is 40,000 people. And then in 1950, right here, we had 45,000 people. That 1,000 is going to be important in just a minute, okay? So let's look at our change right here. From 40 to 45, we can say this is a change of 5, right? And then from 1930 to 1950, that's a change of 20. So when I do this problem, and I look at my change in y compared to my change in x, what I can see is my change in y was 5. My change in x, my years, was 20. Now here's where this problem gets tricky. My population did not just change 5 people, did it? It changed 5,000. So before we make this a unit rate, we want to make this 5,000 people over 20 years. And now we can do this division. So we'll do 5,000 divided by 20, and we see that our average rate of change is going to be 250. And what that means in the context of this problem is that we got 250 people, 250 more people every year. Okay, the population increased 5,000 people in 20 years, or 250 people each year.